Kepler's laws for the planets. The motion of planet is also called planetary motion. These laws are based purely on heliocentric theory, not on geocentric. First law, Kepler's first law, that is known as law of orbit. First law is known as law of orbit. It says that the planets move around the sun in elliptical path. There are the number of foci 2, but sun is at one of the two focus and the planet moves around it. When the planet is at greater distance from sun, at a smaller distance from sun, its velocity will go on changing. Then second law is known to be law of area. It says that the line joining the planet, see, this is the figure that has been shown here for the planetary motion. This is the location of sun here, and suppose the planet is at this very point, so we just imagine this line. This line will cover certain distance in certain time. The law says about the area covered by this line. It says that the line joining the planet with the sun sweeps out equal area in equal time. Actually, this law, what we are discussing here, this law becomes another form of conservation of angular momentum. Angular momentum, you know, MVR. And its conservation means MV1R1 will be MV2R2. That means V into R constant, or better to say V proportional to 1 by R. What is the conclusion of this second law? It says V and R are inversely proportional, means this type of graph. Greater the distance of planet from the sun, smaller will be the velocity. If the planet is at greater distance, it will be moving slower, and when the planet is at a smaller distance, it will be moving faster. Now, third law. Third law is known as law of orbit. It says the square of time period, see written here, is directly proportional to cube of distance between sun and the planet. T square proportional to R cube. But this is approximate. To be very accurate, we would say R is semi-major axis of the ellipse. You must know in the ellipse there are two axes. One is major, this one, and the other is minor axis, this one. Semi-major means this thing. This would be known as semi-major axis. So what is this R here? It is simply semi-major axis. T square proportional to R cube. This law is amazingly applicable for satellites moving around planets also. Here, and it says greater the distance, greater will be the time period. This could also be written as T proportional to R to the power 3 by 2.